Hi, and thanks for joining me in my shop this morning. I'm starting out with this radio, an Airline radio, and actually lots of excitement today. First thing this morning, I looked at the image of a black hole on TV. Isn't that something? Boy, I'm sure when I was in high school, black holes were a poorly respected theory put forward by one or two astronomers or physics guys, and wow, now there's an image of one. So okay, exciting stuff. And also just behind the radio in the background here, you can see a whole bunch of tube testing stuff. Now if you're watching my videos as I post them, if you're a subscriber and you're watching them go by each day as I post them, you know I've been working on these tubes here for 5, 6, 7 days, and so I've had enough of that for now. I have a fantastic chart of data here that I will be analyzing, but you know, a week of that is enough for me. I'd rather get on to doing a radio. So now if you're watching this video because it's the first about this radio, then you wouldn't know what all this stuff is in the background. So that's just going to sit there on my bench. I don't want to tear it apart. While we start on to this radio, now a bit of a history on this radio. This is an important part of the history here. Let's switch cameras so you're looking down. The reason I have this radio is because someone gave me one identical to it to fix, and in the process of fixing their radio, I put a drill through a coil in their radio and ruined it. This is the coil out of their radio, identical to this one. So I had to lay out the money to buy this radio to get the replacement for this part and put it into their radio and send them on their way happy campers. And that left me with this radio and this drilled through coil. So the challenge, I bought this over eBay, paid $100 for it. I've never ever have I paid so much money for an old radio like this. Typically I would buy something like this at a yard sale for $5 or $10, and typically I don't even buy radios. But so I have this one. As far as I know, this radio is in perfect operating order. Doesn't look perfect, does it? Except for this coil and the broken dial glass here, which unfortunately is smashed. So I don't know, maybe all the pieces are in there, I don't know. So let's start by taking this guy out. He can't work because the coil is missing, and ponder how I'm going to get this guy to start working again. And I don't recall if I actually powered this one up before taking the coil out of it. I just don't recall. So you see the screws are not the same, so you know there's a history on this radio of people doing stuff to it. Who knows? Including me. Hey, maybe I'm the guy who didn't put the who put the wrong screw in. I just don't remember. So I'm going to take it out of the back there. I'll get it out of the cabinet here. Okay, only 2 screws holding this radio in. Holding in the chassis. Cord is cracking right here where it bends tight, but it looks like it's safe to operate. But, about the rest of it here. Let's just take a quick inspection. I've been fooled by these in the past, where sometimes cracks or some other kind of damage that's actually exposed conductors. Look at right in here. This feels very hard and stiff, so I don't know why a section of it would go like that, but probably this is going to break out at some point and you're going to have a bunch of bare copper there. But for now, I think it's okay for here in my shop. I'm going to throw a little tape on that, I think, just to make sure I don't have I was going to say an unexpected surprise, but then I guess all surprises are unexpected, eh? this electrical tape, this particular brand, isn't nearly the best, but you are supposed to stretch it a little bit as you apply it. The good stuff, you stretch 50% of its length as you apply it. This stuff you can't stretch that much, but a little bit of stretching, even just a little bit, is going to make this a lot better than if you don't stretch it at all. Crack right up to here. There we are. That's better. Okay. Right at the end there. Good. Looks good. Non-polarized plug, of course. But I see there's a transformer in the radio, so this is a pretty old radio. Got some glass falling. Okay, so the speaker's on a wire and the wire is plugged in, so I'm going to release the plug here. Pretty old tubes. There's a lot of rust on the chassis, I can see now. There. So this radio came to me from Texas, I believe, if I remember right. Somewhere in the southern states. Here's the glass. That's the whole thing. And so it's been blasting out on the camera. This white piece here has obviously been added in by a previous person working on this radio. Maybe to perhaps this has been replaced, or maybe put the cardboard in to kind of flatten this out somehow. Feels just fine to me. I'd rather leave the speaker in there if I can. So it's got 4 wires. So it's got a field coil. Oh, these wires are in bad shape up here, right where they're heading for the field coil. Oh, that's not good at all. I think we need to take a closer look at that. I'm just going to hold it up to this camera here. See what we can see here. So, yeah, this is really not a good thing at all. The this is coming across. The insulation is lost, at least on one wire here. I gotta get the other close-up camera. We need to take a really close look at this. This could be a problem that if you don't take care of it, it's going to haunt you for sure. I have to stop for a moment, get my other camera happening. Just for fun, there's a look down into the tuning capacitor of this radio. Turn these plates. Oh my gosh. That actually feels pretty good turning them. But look at the rust and dirt in there. Yikes. But that's not what we want to look at. What we really want to look at is this speaker wire here. Like if you get a insulation failure right at the, right in the doorway of a coil like this, it's pretty hard to fix it. But you can certainly see the conductor sitting out there. Look at the speaker. Looks like the speaker's been repaired. I'm not sure what that black is. Well, I'm gonna have to take the speaker out to deal with this, no doubt about it. Can't be poking around here. I'm just going to break off more and more of the insulation if I do that. glues. Oh, what's that? A great big blob of glue? That looks like hot glue on there. Hot glue. What has somebody been doing here? Hot glue. No, no, no. That's not. You shouldn't even call it glue. It's a hot stick stuff. Just call it melted plastic or something like that. Oh boy. This is why I didn't want to take it out. But I got it. Big deal there. Oh my God! Holy smokes! No! Who did that? Oh my God! The dust cone is gone. You're looking right into the voice coil space. Oh my God! I've never seen anything like that. No, don't do this to your speaker. Don't do this. Oh my God, isn't that a mess? Well, put this radio back on my shelf. Oh my God. Wow. Okay, so this puts the brakes on pretty firmly already. Oh, did you hear it crack? So I don't know what kind of glue this is. It doesn't... Yeah, it's the same stuff as this. Oh my God. What has somebody done to this speaker? We really need to test this speaker out before I go any further with this radio. Because if this speaker is completely shot, I'm in big trouble. Because it's a field coil speaker. Oh my gosh. Well, we got to test this thing, and yet, frankly, I have never tested a field coil speaker just on its own. But I'm going to figure out how to do it. There really is no reason to go further with this. Let's just take a peek underneath. Oh, new capacitors in there. Somebody took, look, what's this? Cut, 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 cut. What's going on here? These are all cut away and left. Like, why would you cut away this part but leave it hanging there? You know, there's an answer to that question. I've done that once in a while, and it's to indicate what was there before I replaced it. I don't know, you know, at a glance this just looks like it doesn't have enough parts underneath it. Somebody put the time into it, though. I was looking for something, a new challenge. Wow, did I ever find one? How come they didn't bother changing this up here? They didn't bother, unless this work was done decades ago, which I don't think it was. Well, it could have been done decades ago, but these tubes have been never cleaned. These are never cleaned. Probably means they've never even been pulled out. Chassis all rusty. Oh my gosh, if it wasn't for the beautiful cabinet, I wouldn't think even twice about... Well, you know, I would think twice. Oops. But I wouldn't think 3 times. Well, let's prove out this speaker. If I can get that done today, that's a good day. A good day in Jim's shop. Now, we'll take a close look at the wire problem here. So one is still insulated. The other one, the insulation is given right out, right in here. So I need to reinforce this, and then I need to stabilize this so it doesn't go anywhere from now on. It just sits in, so that this is no longer flexed. And I think I can do it by just locking the wires onto this bracket here somehow. Can I just leave that? I just don't think it's good. Can I just stick some tape in there and do something ugly? Yes, let's do that. See, the thing is, this is going right into the field coil, which means this is coming right out of the high voltage power supply. This has got the power supply high voltage current flowing through it, and I'm sure this coil is elevated in voltage above the chassis on the radio. So this wire, you know, like you could do this, right? You could say speakers have no dangerous voltages on them. That's what I think. Reach in with your hand, touch the chassis, touch the short. Oh boy, wouldn't that have you jumping? So yeah, we really do need to cover that up. And when I was a kid, I knew speakers had no serious voltage on them. I didn't know about field coils for a while anyway. Just so happened the first few radios I played around with as a kid had permanent magnet speakers in them. And I didn't read about field coil speakers. I didn't know anything about it. You know, it's pretty tricky to read back. I mean, we're talking about the early 70s. Where would you go to read about a field coil on a speaker? You could go to my little town public library and read it there. Well, there was actually a couple books in the town library, just a couple. It's called The Boy's First and Second Book of Electronics. Does that ring a bell with any of you? And those books opened my eyes to the, I don't want to say science side of it, the engineering side of it, the mathematics side of it. Whoops. I have acquired a copy of those books. I have a copy of The Boy's, I think it's first, second, and third book of electronics now. I just saw them at a yard sale one day and thought, oh, you know, that's a piece of my history there. And why am I talking about that? Because back when I was a kid, I could have easily been the guy who I could have been that guy. Okay, so we need to stabilize this a little bit anyway. And what it's going to do is it's going to move the stresses to a different location. There shouldn't be any stresses, should there? Once this is back in the radio, you know, there's none of this going on. So, if I thought the radio was functional enough, I would plug it in there and start experimenting with the radio itself. But I know it's not. It's missing a coil. I don't even know what this coil actually does in there. It looks like an antenna coil to me, so maybe this isn't so critical, the coil. So we're going to have to operate this guy outside of a radio. So putting a signal on the voice coil is easy. Putting a signal on the field coil, and I shouldn't say signal, putting a current through the field coil. Never done this before. So field coils, resistance, I'm going to guess. We don't have to guess. We don't have to guess. Let's not guess. We're not guessing today. We are going to make our mistakes directly today. Why guess your way into an error when you can measure your way into one? Okay. So we're ready to read resistance here. What we should find is a very low resistance on the field coil. So I see there's two big prongs, two small prongs. My guess is the big ones run the field coil. Let's see what we get. Did we get anything? So that's 1,000. Whoops, I had it there for a moment. 1,700. I thought I saw it. Yeah, 1,700 ohms. Now the other one we should see, well, it might even see a 0 on this meter right now. Yeah, no, that's not what I'm looking for. No, not that. Don't give me that. Okay, so then my opening theory is wrong. What happens if you go between the big and the small? Nothing. That's good. Okay, so there are definitely two different circuits here. Which one's which? So probably if I put a little current into either one of them, I was going to say one of them will make sound on the speaker. Actually, both of them might make a little bit of noise. 720 ohms. That's just nowhere near what I'm expecting. And this one, 1700 again. So I thought, okay, take it back. Look what I'm doing here. Wake up, chum. So the output transformer's here. So I can see. Oh my lord, I can see. These two wires are going into the output transformer. I can see them. Let's not fiddle with that. So there are two lighter wires, two heavier wires. I don't think it's the conductors. I think it's the amount of insulation. So the better insulated wires are the higher voltage ones. So there's the two large pins, and there's the two large wires going into the large pins. So the large pins are definitely okay. Solve that. A little extra effort there, but it is solved. Now, how am I going to do this? So I got to put some amount of DC current through here. These power supplies are probably typically running only a couple milliamps through a coil like this. So I could get a couple milliamps going through it in a couple different ways. I could use my high voltage supply, just not turn it very high. I got to think about the convenience in my shop here too. Or I can do it with a low voltage. You know what? I have an ideal low voltage supply sitting here doing nothing. Let's use that. Righto. That's these guys up here. We'll use him. I believe those two power supplies I bought at a yard sale here in Aurelia. Can you believe it? Those two things were out for sale for a couple of bucks each. And the guy who was selling them even knew exactly what they were. I took one look and thought, these are wonderful shop supplies, and they are. Hewlett Packard. Another lucky win for me. So we'll leave the output level 0. Even the little light didn't come on, but this is on. Trust me. I'm going to hook it up back here. And just hook it right up here. Now I'm going to turn the, it already is set. So there's 1 meter in the power supply, but a switch for volts or amps. I got it switched on to current. So even with it set to 0, there may be something there. I don't hear anything. I don't see anything. So what I'm going to do, I'm going to raise up the output of this power supply here on milliamps. So this is a quarter of an amp, 250 milliamps full scale here. So if I want to just put a couple milliamps, it's hardly up on here. Hardly up. Wow, barely see it. So what's the most current you could put through a coil like this? Some radios might be drawing out of their power supply, and most of it is busy working the speaker. Working like most of the power coming out of the power supply is being used. It's not quite true, but being used to drive the speaker. That's what the radio is all about, right? Getting the speaker to go. I don't know offhand. Probably 10 milliamps is probably safe. It's a great big coil. It'll take a long time to heat up. So I'm probably safe up to 10 milliamps, which is barely on the scale here. Let's go a little bit. Okay. So I think there's some current there. Wow, this is a little loosey-goosey, isn't it? And before I did that, I should have set up the audio signal. Okay, no harm done. No harm done yet. So we're gonna use this. So obviously the other prongs, I already know they're isolated. Wait a minute, you know what? This isn't right. I'm a dummy. How come I saw current flowing? Okay, hold it. Everybody stop. Two light brownish, a light and a dark, light and a dark, light and a dark. Two fat pins I don't know what was going on there. Was that my imagination seeing the meter move? I saw that meter move. How did the meter move when it's feeding into an open circuit? Okay, this is working more normally now. So that's going to be 3 or 4 milliamps right there. Okay. I don't know. See, I don't know. Why do airplanes crash? Because people like me are piloting them. That's what I would say. Hey, it takes all kinds of people. Okay, so we should hopefully hear this coming out of the speaker. So what I think I've done is I've set up a magnetic field in the field coil that the voice coil can work against. That's the whole idea. Let's give it a little bit of tone here. We're at 300 hertz, which is a nice, easy to hear sound. Well, I'm not having an easy time hearing anything. It's a no response situation here, which means maybe things aren't working the way I think they are during this test. Which means I have to convince myself of everything here. Oh boy. Let's start with the signal that I'm putting on the speaker. Now here's a permanent coil speaker. I know for sure it works. Now the sound's going to come out of it inverted because I have the speaker upside down, but I think that's okay. Okay, so pull the correct leads off here. Yeah, pull the correct leads off. I want to pull my ears off, make sure this is turned. Whoop, I'll turn it right off. Just keep it down. What do we hear? I hear it already. There it is. So that's what we're sending. Let's raise it up here. Okay, it's just a little more noticeable. So that's that we should hear exactly this at this kind of volume level coming out of that speaker. And if we don't, it's time to sing the blues already. Here we go. Nada. Not a thing. Well, I think the next thing to do is, you know, if your car isn't going fast enough, you just step harder on the gas. So first we'll raise the voice coil signal way up. I'm going to raise it up in frequency even higher. Okay, so we're up around 1,000 now. Oh, I hear a little bit. Okay, so we'll leave this so I can hear it. You can probably hear that too. All right. I find that easier to hear. And now I'm going to change the current flow through the field coil because maybe I just don't have enough, or I don't really know. I don't want to take the time to measure it. Okay, one second here. Look at that. Pull out the field coil and still hear the tone. That's not too surprising, is it? Not to me. So you can hear that difference? So I'm going to turn up the field coil current. It's up around 10 milliamps now. It's interesting, it works. So there must be some residual magnetism, or somehow the cone is able to push against something magnetic in there. Maybe just the steel? Let's try that. So I'm just trying to feel if there's any magnetism. This bracket may be aluminum. Well, let's check that. Definitely not aluminum. So there must just be a little bit, even though I can't really feel it. Must be a little bit of magnetism left. Yeah, I can feel it there. So a little bit of magnetism left in here. Was there ever a combination permanent magnet electromagnet speaker? I don't think so. That's why we can hear it. Still putting the 10 milliamps through here. 1700 ohms, 10 milliamps. So it would be 1.7 times 10, 17 watts of power dissipated in this coil. Just trying to prepare myself for burning this out. So, well, anyway, when I do, I'm gonna read. There's no current in the field coil. I'm gonna put the field coil lead back in. Just listen. Let's go a little higher on the current. So that's easily 10 milliamps of current. So what do we know? We know the speaker works. We don't really know what it sounds like, though. I mean, I got to get some volume out of it. Well, I'll leave because I don't know for sure what I'm doing to this coil yet. We'll leave the current off, and I'm just going to crank up the input level to the voice coil. I can barely hear it now. And that's it. That's all I got here coming from my signal generator. It's just flat out. It's a lot louder coming out of that other speaker, I'll tell you. Okay, with this thing flat out, I'm going to put back in the field coil and crank up the current. Okay, so I put it all the way up to 40 milliamps. 40 milliamps. I squared R, right? 40 milliamps. I can't do it in my head. Well, I can do it. Get a number. I can't do it and believe what I've done. So I don't want to leave all that current flowing through there. 50 milliamps sounds pretty big for high voltage supply. So let's do this. I'm going to set the signal coming through here to sweep from a low frequency up to a high frequency. We'll listen to it sweep right through its frequency range, as quiet as it might be. And I can aim this up at the speaker, in fact, like that. But what the reason I'm doing this is well, first I want to see that it works. Okay, it works. Secondly, does it buzz? I mean, look at it. Probably the reason this thing is so quiet is it's glued. They glued the speaker. So, I mean, huh. Wow. Okay, let's do the sweepy thing. So we'll start it down low. Way on the down low. .100 hertz. We're going to start it at. You can kind of read the number up here. And then we're going to let it go all the way to okay, I can hear that. 6,500. No, that's 6,000. We'll go to, yeah, I can kind of hear that too. That's 7,000. The 8, you know, I'm not sure I'm hearing that. So we'll let it sweep through here. We'll let it sweep up for 10 seconds to sweep up. Sine wave. Let her rip. Okay, I'm going to start this again. That was fine. I'm getting an impression of what the story is with this speaker, I think. Let's just make it sweep through the lower frequency ranges here. So I'm trying to get it to sweep, let's say, from very low up to, better make it 300, to where we can barely hear it. So it's gonna go to just under 300. It's gonna start at 100. I want it lower. Oh, that's lower. 50, 30. Just a second here. Okay, so it's going to sweep from around 40 hertz, which is crazy low, up to almost 300 hertz. And it's doing it now. I didn't hear any of it. I didn't hear any of it at all. Let's get it to go up higher and make it go a little faster. It's once a second now to sweep up. So we should hear whoop, 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 like that. I don't hear anything. Let me let it sweep up much higher yet. Okay, I'm going to put a little current through the field coil. I think I know the story here, though. Okay, so that last bit was with 30 milliamps flowing through the field coil. Now I'm going to have to find out what is a typical current in a radio like this. You know, I just don't really know. Would it be that high? 30 milliamps? I got to look into this a little bit. Okay, so what I'm going to do here, a good suggestion I found on the internet is, if you're testing the speaker, you should really put in a regular speaker voice coil signal, maybe out of a radio. So I grab this radio, battery operated radio, and I'm just going to run wires to the voice coil here. And so that's to provide a kind of normal range signal to the voice coil, because I'm doing it with a power supply, I'm doing it with this sweep generator. I really don't know that I'm supplying it with anything normal. So that's what this is all about. And then I have this speaker here because I want to check what I'm doing with a known speaker before I start concluding things. And did I say about the 50 milliamps? I can run 50 milliamps through this voice coil. 1500 ohms, 1700 ohms, going to generate 5 watts or somewhere in that range. That's not enough to worry too much about, certainly not in the short term. Okay, so we want this to be, just going to use this plug here like this. Okay. What should we listen to? Something on, I know what we should listen to. want music, and that's exactly what's on it. That's okay to start. So first we'll plug this in and hear it come out of there. We can set the level then. Sometimes these ear plugs are just straight into the speaker. Sometimes they have a resistor in there. This one sounds like it's straight into the speaker. Where'd the radio station go? So that's what's possible. Hear the volume level? Turn it up. Don't, you're going to get me a copyright hit. Okay, so we know now what level is going to come out on these clip leads. So we're going to put the clip leads onto the speaker voice coil. And we're going to crank 50 milliamps through the field coil. And we'll know what to expect with this speaker. In we go. Okay, switch on. Wow, that's not quite what I was expecting. It's nothing. 50 milliamps through the voice coil now. That's 30 milliamps. And I hear a thing. Something wrong with my test. Let's turn up the volume here. It's full blast. Let's flip the antenna around here. Even the sound quality is poor. What does it matter? There's no volume. There's no volume. Turn it back down. Now, for sure we've got current flowing because I'm actually seeing it on the meter up there. There's no doubt. There's 30 milliamps going in there. Let's crank it up to 50. Can't get there. That's full tilt from that supply. That's with the current and without it. Okay, so here's my conclusion here. This speaker is really hobbled by all this glue. The output volume is extremely low on it, probably because of two effects. One is maybe, well, two effects. Well, one is all the glue, who knows why all that's done, but the other one is the cardboard is very light, it has almost no mass, right? So it's easy to be driven back and forth, but it's been headied up with all this glue. So there must be, I don't know, 50 times the mass here that the speaker is now trying to drive. So I think what's going to happen is the high frequencies are going to come out, you're going to hear them because it doesn't take much movement. The low frequencies are a lost cause in this speaker. And that's kind of what I've demonstrated, although the other problem with it is it just has no volume at all. There's no volume, again, probably because of what's been done to the cone here. And so I'm saying I don't think there's anything I can do to make this sound any different. Okay, so I'm doing something here that I don't normally do. You're watching this video, and what you were watching is what I was working on and preparing as a video, and I got to this point and realized I'd made a huge mistake, and the rest of the video is based on a huge mistake. So I'm replacing the end of the video, which you're not going to see. I will tell you what my mistake is. I'm going to correct my mistake and test the speaker properly. So what I started doing was feeding a DC current into the field coil. That's fine. And I started feeding what I would hope would be a voice coil signal into these two terminals, dumb, because these two terminals go to the primary of the output transformer. I forgot it was up here. So I was thinking I was hooking them up to the voice coil. The result of that was virtually no output from the speaker, and me concluding that this thing is a complete write-off. You know, I still think it is a write-off, but my test is bogus. So we're going to improve the test by feeding the test signal right into the voice coil. Oh my gosh, look at it in there. Look at how bad this is. This is just... See, I think he's replaced part of the cone under here. You can't really see it. And here the cone is connecting to the voice coil form just fine, but up here it's nowhere near it. Yeah, a piece of junk. Why do I even bother? This speaker is never going to work well. Why would I even bother testing it? Just to convince myself. That's the only reason. Okay, let's do that. Let's convince myself. So I can still hook up a DC current to it here. Okay, so that'll energize the field coil. Put 20-30 milliamps down the field coil, and now the output from the signal generator here, we're going to start with that. I'm going to put this right on the voice coil leads, which I'd love. Let me see if I can get this one. It's not good to try to clip right on the actual leads now. I don't know if I can get it. It's so dirty in there. I don't know what I'm clipping on. That might do it. Okay, sit here. So first thing I'm going to do is put the DC into the field coil. That's about 20 milliamps of DC. Now we're going to pop this guy back on here. So yeah, it shut everything off because I was doing the final preparation of the video. So we're sweeping up at 1 per second. I don't hear a darn thing. Let's put a little sound down to it. Okay. Now we're getting a little more volume out of it. Let's listen to this thing. Can't get my camera to focus on it, but okay, I've heard enough there. So I'm hearing a lot of problems in the speaker. It doesn't sound like a nice mellow tone. It sounds like it's buzzing all the way through practically, and then the buzz degree is going up and down. There's certain spots where it's even more buzzy. Doesn't sound very good to my ear at all. Let's hear it again. I hear a low buzz right in the middle. There's a faint one, and then at the top it's buzzing again. That's what I hear. Well, I got a little more volume out of it because I'm putting the signal more directly into the voice coil. But let's listen to a radio through this. Now, again, the field coil current is around 20 milliamps. That's probably a little low. We'll fiddle with that in a minute.
So why, at this age,
We'll listen to this.
want to participate in an activity that requires a bathing suit? Let's put a gaggle of people with urgent bladder syndrome in an aquarium of warm water and hope for the best. Where the only danger of a sport injury is when you swallow all that E. coli. That's why they make you lift Jabex bottles as weights. You can lift and disinfect the entire pool at the same time. And people who do aquafit, they don't brag about that. They sheepishly grab and noodle like they're in the Aqua Fitness Protection Program.
Okay, I think I got it clicked on. This is a CBC radio show called, oh, I can't remember, The Debaters. They use comedians to debate stupid questions. So. But let's put the sound through here. Wait a minute, we want to have the same volume.
You know what's really good through your joints?
I'm not hearing much here. Okay, turn it way up. So you can hear the hiss, but you can't hear the voice. And I think that's because the bass is so badly suppressed in this speaker. And bass being right up to 1,000 hertz, or even higher. But the very, very high stuff is not suppressed, because it doesn't take much movement to produce the sound. That's my theory. Let's turn this down here, and pull it back out and hear what it sounds like for real.
Leg to stand on. Use your noodle. And think of every joke. From A to Z and H2O. Because after all, what are debates for?
Okay, that's typical Canadian humor there on the CBC. So, we definitely have a current in the field coil. That's what you hear at the same volume level. Now, you know, this transformer is still connected here, so maybe this is another invalid test in the sense that the coil here is robbing the speaker. But I've done this kind of thing before. You can't be robbing it of that much. Turn up the volume here. And then I'm going to turn up the field coil current. A little more volume. That's almost no current. And that's 30 milliamps through it. Okay, you know, I'm going to go back to using the sweep on it and see if I can produce a sweep test signal that will highlight the same weakness in the speaker that I believe is there. It can reproduce high sounds, but it's glued in place for low sounds. That's what that amounts to. So I was sweeping up to, I don't know, what was I sweeping up to? I was sweeping up to 900 hertz. I want to go a lot higher than that. Just start high and go high. And what I'm expecting is we'll see that the lower tones barely come out and the high tones come screaming out of the speaker. Okay, I think I got that connected. Once again, let's get some current in the field coil. That's 38 milliamps of current in the field coil. Yeah, when I turn the volume up, you can hear the terrible rattling distortion. This speaker is really a piece of junk. So we want to start at start there. Start there. Start there. There, that's better. We'll start there, and we're going to go up to. Can you hear that? It's probably coming across. I find the YouTube recordings very, very good sound quality. So that's 9 kilohertz. So we're going to let it sweep 1 second through that. Okay, I give it a little more volume. So it actually sounds pretty good. Let's lower the starting frequency here. Oops, lower the starting frequency. 700 hertz. 400 hertz. We'll start it at 400 hertz. And volume up. I'm going to stop it at 400. Now the problem is if I put this, I will do this, I'll put this into a regular speaker and we'll hear how loud this really is, because I've never done that. I don't really know just what kind of juice is coming out of that. Let me grab my speaker. just gonna make exactly the same sound. Let me have it sweeping for fun. I'm going to turn the volume down here because I expect it to be loud out of the speaker. I don't want it too loud, so I'm going to turn it down. Okay, everybody register that volume level. This is what a good speaker sounds like. That's the same volume as the speaker over there, so it's almost inaudible. So this speaker, inaudible. Yes, that coil is there. And back to the test, the reference speaker. Yeah, right. So now we'll try this with a high frequency. Let's go way up. Okay, so that's 4,000. We can go higher. 9, that's too high. Oh, I see the problem. Okay, let me select it this way. So I can still hear that. It's just shrill in my ears. Plenty of volume for that tone. Okay, and now we're going to switch to this guy. It's very hard to use your memory on sound. Very hard. Okay, clip on this time. Okay, it's on there. I don't hear a thing. So you're hearing nothing, and then suddenly, whoosh! That's because you can't hear the first part of the ramp up. So we'll do that by hand here. Starting to fade out now. 600 hertz, 650 hertz. Really leaving at 400 hertz. It's just about gone. You can see that frequency here. Give it a little more juice. You can hear it, but it doesn't sound like a mellow tone. A bit of a buzz to it. Well, that's 300. I'll go up. See in there, it sounds terrible. Okay, one last chance, Mr. Speaker. You're going back on the little guy here. First onto the good speaker. Output from here. Volume check.
I was so excited about this announcement, I didn't even sleep.
This is how loud this thing will go. Watch your ears.
West Toronto, Premier Doug Ford touted the province's plan for the city's transit system.
We're creating a truly regional subway transit plan.
The expansion includes the downtown relief line renamed.
Oh my God, I just... You know, listening to American news is pretty bad, but listening to Canadian news, there's a lot of stuff going on here. It's pretty upsetting to me. Nothing at all like what's happening in the States. Nothing at all. So, You heard how loud it is. I got upset there. Threw me off. That's the way it is today, isn't it? A couple of minutes of news and you're upset. Okay, so the objective here is the full volume check. I don't think there is any. Full volume. Okay, for what it's worth.
And what type of new technology the province wants to use on the relief line. Lisa Shank, CBC News, Toronto. Refugee advocates are...
Yeah, lots of distortion in there. I'm pretty sure the distortion we just heard, even if the output of the transformer is being suppressed because this is sitting here while I'm trying to shove a signal into it, the suppression of the signal wouldn't result in that kind of distortion. I mean, come on. Look at the speaker. It's really, you don't need too much more than a look at this to realize this is really in bad shape. So on the last time around, I did very similar tests here on the part of the video I'm not going to post, but I've arrived at exactly the same conclusion. That is, this is the oscillator coil, not the antenna coil. I was hoping this wasn't the antenna coil. It's the oscillator coil. For this radio to work well, this coil has to be exactly right. For this radio to work really poorly, for the dial to be off, to have weak output, because of this, I can remake this coil myself, stick it in there, and that's what we'll get. Really bad performance. And bad performance into a piece of crap speaker. In a rusty old radio. In a beautiful cabinet. So this radio is going back to being a showpiece radio, and too bad. Maybe I can do something with this glass here. Somehow make it look better, because it's not going to play better. So I've reached the same conclusion. I spent a longer time doing it on the original video, but same deal. So please, don't do this to your speaker. Don't. Thanks for watching. See you in the next video. I gotta get another radio in here. I gotta get a radio to fix.